For all of human history, the moon has been our silent, constant companion in the night sky. We've seen it as a deity, a destination, and, well, a dead world. But recent events have shattered that last perception. A groundbreaking discovery by China's space program has confirmed that our moon is not a static relic, but a dynamic body teeming with resources that could, honestly, redefine humanity's future, turning science fiction into scientific fact. So, what did they find, and how does it connect to the decades of mystery surrounding our moon? Let's dive in. Anomalous lunar structures. The conversation about inexplicable objects on the moon often circles back to a single pivotal mission, the 1994 Clementine mission. This was not a standard NASA science mission, it was a joint project with the United States Department of Defense's Ballistic Missile Defense Organization. Its official purpose was testing advanced lightweight sensors by mapping the moon, but its military oversight has, fueled speculation that its agenda was more than purely scientific. From the massive trove of 1.8 million digital images it sent back, a few select frames have become legendary within circles that investigate lunar anomalies. These images, especially from the perpetually hidden far side of the moon, appear to contain features that defy easy geological explanation. There are patterns that look unnervingly geometric, with straight lines and sharp 90-degree angles that some interpret as the weathered ruins of immense ancient structures. The most famous of these is a feature that strikingly resembles a massive three-sided pyramid. While the scientific consensus attributes these oddities to a combination of digital image compression artifacts and the deceptive play of light and shadow across an alien landscape, many researchers remain unconvinced. They point to what they see as signs of deliberate censorship, like patches of unnatural blurring or obfuscation, suggesting that the Clementine mission was, in fact, a reconnaissance flight to get a closer look at something that was already known to be there. Ancient astronaut connections. The intriguing possibility of lunar ruins feeds directly into the wider, captivating theory of ancient astronauts. This hypothesis suggests that intelligent extraterrestrial species have been visiting Earth for millennia, and that their influence is recorded in our oldest myths, artworks, and sacred texts. This lens reinterprets our history not as a story of primitive superstition, but of misunderstood technology. For instance, a persistent piece of UFO folklore is a supposed secret transcript from the Apollo 11 mission, where Neil Armstrong allegedly expressed shock at seeing massive alien craft and structures. A story that has been thoroughly debunked by NASA but, continues to circulate. This narrative is woven into reinterpretations of ancient texts, such as the Sumerian cuneiform tablets. In one tale, a godlike being from the Anunnaki advises his son, before a journey to the moon, to wear his eagle's mask. Proponents of the theory argue this is a clear description of a helmet, a piece of life support technology. This same re-examination is applied to ancient art across the globe, most notably the Wandjina cave paintings in Australia. These ancient artworks depict beings with large, dark eyes and heads surrounded by a halo-like ring, which look remarkably similar to a modern astronaut viewed through the visor of their helmet. The question the theory poses is a powerful one. Were our ancestors painting gods, or were they painting visitors? China's groundbreaking discovery. Moving from compelling theories to verifiable facts, China's space program has recently delivered hard, verifiable evidence that is, in its own way, just as revolutionary. The nation's Chang'e 5 mission was a masterpiece of robotic engineering. In December 2020, it successfully touched down in a previously unexplored region of the moon, drilled into the regolith to collect samples from beneath the surface, and then returned 1,731 grams of lunar material to Earth. It was the first time in 44 years that humanity had brought back a piece of the moon. After more than a year of intense analysis, Chinese scientists made two monumental announcements in 2022. The first was the identification of a completely new mineral, a phosphate crystal they named Change Site Y. This placed China in an exclusive club with the United States and the former Soviet Union as one of only 3 nations to have discovered a new lunar mineral. The second discovery, however, had even more profound implications. They found definitive proof of water, not as ice, but as molecules trapped inside tiny beads of glassy material forged in the heat of ancient asteroid impacts. This finding completely changed the scientific understanding of lunar water, proving it wasn't just isolated at the frigid poles but was, in fact, distributed far more widely across the moon's surface. revolutionary implications. So, this confirmation of widespread water on the moon is honestly a watershed moment for the future of human space exploration, because it really validates the concept of in situ resource utilization, or ISRU. That's the principle of using local materials to create what you need to survive, instead of hauling everything from Earth. For decades, the dream of a permanent lunar base just seemed totally out of reach, mostly because of the massive costs involved in launching all the water, oxygen and fuel required. But China's discovery, well, it completely reshapes that calculation. Even though each glass bead contains only a tiny amount of water, the sheer volume of lunar soil means there could be as much as 270 billion metric tons of water up there. Future missions could send rovers to heat the soil, releasing the trapped water as vapor, which could then be collected and condensed. This water would be absolutely vital for drinking and for irrigating crops in lunar greenhouses. And perhaps even more importantly, electricity can split the water into its base components: breathable oxygen for life support, and powerful hydrogen for rocket fuel. This really transforms the moon from just a desolate stopover into a self-sufficient exploration hub, and honestly, a fully functional gas station for missions heading deeper into our solar system. The Chang'e program evolution. China's lunar triumphs aren't just the result of a single lucky mission. They're actually the culmination of a patient, multi-decade and brilliantly executed strategy called the Chinese Lunar Exploration Program, or CLEP. This program was designed as a deliberate three-step progression, each step more complex than the last. The first step was becoming a lunar satellite state, pulled off with the Chang'e 1 and Chang'e 2 orbiters. These missions created high-resolution maps of the entire lunar surface and identified potential landing sites for the future. The second step was achieving a surface landing, and that milestone was reached in 2013 with the Chang'e 3 mission, which deployed the U2 rover, a major national achievement. Then China showed off its advanced capabilities with the historic Chang'e 4 mission in 2019, pulling off a world first by successfully landing on the far side of the moon. That took a dedicated relay satellite to solve the communication blackout problem. The third step, which was the most complex, was sample return. The Chang'e 5 mission nailed this in 2020, performing a landing collection, a launch from the moon, a robotic rendezvous in lunar orbit, and a safe return to Earth. This methodical step-by-step approach has really shown without a doubt that China has arrived as a top-tier space power. Resource revolution on the moon. The samples returned by Chang'e 5 have honestly unleashed a scientific revolution. They've recast our view of the moon, so it's not just a geological artifact anymore. It's a vast repository of strategic and economic resources. The discovery of the new mineral, chang'e Y, is more than just a novelty. It's significant because it's a phosphate mineral containing helium-3, which is extremely rare on Earth, but has been sprayed onto the moon's surface by the solar wind for eons, getting trapped in the top layer of regolith. A lot of physicists consider helium-3 to be the ideal fuel for nuclear fusion, which is like the holy grail of energy production. Fusion reactors powered by helium-3 could generate huge amounts of clean energy, with no greenhouse gas emissions and none of the dangerous long-lasting radioactive waste you get from today's nuclear fission plants. The ability to mine helium-3 on the moon could, one day, actually secure humanity's energy future. Beyond that, lunar soil is also rich in rare earth elements, which are vital for making everything from smartphones and electric cars to advanced defense systems. So, the moon could become a critical source for these materials, helping to ease the environmental damage and geopolitical tensions that come with mining them here on Earth. Future lunar colonization. With the confirmation of accessible water, a potential source of near-limitless energy from helium-3, and abundant construction materials, the vision of a permanent human settlement on the moon has leaped from the pages of science fiction into the formal strategic planning of major world powers. This vision took a significant step toward reality in March 2021, when China and Russia officially announced a joint partnership to build the International Lunar Research Station, or ILRS. This is a profoundly ambitious project to establish a permanent and eventually fully autonomous scientific outpost near the moon's south pole. This location is highly strategic due to the presence of large quantities of water ice believed to be trapped in its permanently shadowed craters. The ILRS is designed to be a hub for scientific discovery, technology verification, and large-scale resource extraction. It will serve as the crucial proving ground for the systems and technologies necessary to sustain human life for long durations in the harsh environment of deep space. And underscoring the seriousness of this commitment, Chinese space officials have stated their intention to have a nuclear power plant operational on the moon by 2028 to power the station's construction and early operations. Lunar resources, the new gold rush. The definitive discovery of vast and valuable resources on the moon has officially ignited a 21st-century gold rush. This has created an intense geopolitical competition to claim and control the most strategic locations, turning the lunar South Pole into the most sought-after real estate in the solar system. This land rush, however, is taking place in a dangerous legal vacuum. The foundational treaty of space law, the 1967 Outer Space Treaty, is clear on one point. It explicitly prohibits any nation from making a claim of sovereignty over the moon or any other celestial body. No one can own lunar land. However, the treaty is critically vague on the issue of resource exploitation. It does not provide a clear legal framework for whether a nation or a private company can mine lunar resources and claim ownership of them. This ambiguity has created a high-stakes race where the prevailing logic is that possession is 9/10 of the law. Nations are now rushing to establish a physical presence, to land rovers, build habitats, and demonstrate resource extraction, in the belief that these actions will establish a de facto precedent, strengthening their position in future negotiations over who gets to write the rules for the lunar economy. International space race. Today's race back to the moon is a fundamentally different beast from the two-horse race of the Cold War. It is a global, multipolar, and heavily commercialized affair. One of the principal efforts is led by the United States through NASA's Artemis program. The goals of Artemis are not just to repeat the achievements of Apollo, but to go further by establishing a sustainable, long-term human presence on the moon, with a landmark commitment to landing the first woman and the first person of color on the lunar surface. The defining characteristic of the American approach is its deep and unprecedented partnership with the private sector. Instead of developing all of its own hardware in-house, NASA has embraced a commercial model awarding multi-billion-dollar contracts to companies like SpaceX and Blue Origin to build the landing systems that will carry its astronauts. This collaborative philosophy is legally enshrined in the Artemis Accords, a US-led international agreement that sets forth principles for peaceful and transparent cooperation in space. With dozens of signatory nations, it forms a broad coalition built on a shared vision, standing in contrast to the more state-centric models of its global competitors. Competition between China, US, and other nations. The geopolitical chessboard of this new space race is rapidly organizing into two primary alliances. In one corner there is the US-led coalition of nations that have signed the Artemis Accords, which includes established space powers like Japan, Canada, and the member states of the European Space Agency. In the other corner is the burgeoning partnership between China and Russia, centered on their ambitious plans for a joint international lunar research station, which is steadily attracting its own international partners. However, this is not a simple bipolar conflict. Other nations are carving out their own paths and emerging as significant independent forces. In a spectacular display of technical skill, India's Chandrayaan-3 mission made history in 2023 by becoming the first nation ever to achieve a soft landing near the lunar South Pole. This historic achievement instantly established India as a major player and a critical contender in the search for lunar water ice. The current landscape is a complex and dynamic interplay of national ambition, commercial interests, and strategic alliances. While intense competition is currently driving innovation at a breathtaking pace, the sheer crushing difficulty and expense of operating on the moon may ultimately force these rivals into a new era of global cooperation. The moon is no longer just a beautiful light in our sky, it's a destination, a resource depot, and a critical stepping stone to the rest of the cosmos. China's discoveries have opened a new chapter in human exploration, one that will challenge us technologically and force us to decide how we will explore these new frontiers together. What do you believe is the most important resource the moon has to offer? Share your thoughts in the comments. Don't forget to like, subscribe, and hit the bell icon for more explorations into the science and wonder of our universe. Thanks for watching Sci and Why.